Welcome to this explainer. Today, we're targeting a very specific engineering challenge, and we're going to completely shift our mindset. We're moving away from building those fragile, happy path demo scripts. Instead, we're learning how to build a rock-solid Deno plus CaptchaAI integration, one that's specifically designed for unattended, automated workflows. So, if you're building automation, you're definitely in the right place.
Let's start by acknowledging a shared pain point that pretty much every automation developer has run into. There is a massive difference between a quick local test and a true production environment. You know, a standard setup looks deceptively simple when you run it locally in a notebook. It works perfectly in 5 minutes. But the exact moment you put it in an unattended CI pipeline, a cron job, scheduled jobs, or behind an internal queue, it fails miserably. It breaks during deploy windows, trips over network hiccups, and completely shatters when the Captcha family on the target page changes. We need an architecture that absorbs all of that automatically.
Okay, so here's our agenda for today. We'll cover the unattended problem, the core workflow, and import maps, run through a production checklist, highlight common mistakes, tackle a developer FAQ, and finish with safe scope and takeaways. Let's get to it.
First up, the core workflow and import maps.
Here's the 5-step core workflow required to predictably handle captures. Think of this as your absolute foundation. First, you capture the exact required inputs. Second, you submit the task. Third, you pull for the result. Fourth, you apply the token in the exact same session. And fifth, you verify downstream acceptance. Now, if you skipped literally any of these steps, your automation becomes flaky. It's really all about shifting from just trying to get a token to tracking true end-to-end acceptance.
Now, you might be wondering why import maps matter so much for this workflow. Well, when you're using Deno, import maps help keep your imports absolutely pristine. They make your helper modules significantly easier to manage across different files. And most importantly, they drastically improve readability for the next maintainer. You really want your automation to be something another developer can read and actually understand in 5 minutes, rather than leaving them with a tangled web of raw URLs.
All right, let's move on to the production checklist.
We'll kick this off with the first 5 rules of the checklist. Number 1, always confirm the workflow is authorized. 2, keep your import maps clean and readable. 3, capture only the required Captcha inputs. We're talking about things like the site key, page URL, action, method, and maybe an optional proxy. You need to inspect the live network call and pull only what the solver expects. Storing more than that just creates false debugging trails later on. 4, treat failed API responses as real errors and surface them to your monitoring channel. And 5, use controlled polling. That means waiting about 15 seconds before the first poll, then polling at a fixed 5-second interval, capping it with a hard timeout of 120 seconds.
Now, the absolutely crucial point on the second half of this checklist is step 6. You absolutely must apply the token in the exact same session that triggered the challenge. That means the same browser context, HTTP client, or cookie jar. Step 7. Track solver success separately from downstream workflow success. They are not the same thing. Step 8. Cap your retries. We want to avoid those infinite retry loops that just burn through your balance. Step 9. Log useful failure details. But please, do it without exposing secrets. And finally, step 10. Strictly monitor latency, retries, timeouts, downstream acceptance, and your overall cost per accepted solve.
Next up, let's look at some common integration mistakes.
There are actually 9 specific recurring mistakes teams tend to make here. Things like using unclear import aliases, guessing capture parameters instead of just capturing them, or storing totally unnecessary page data. Polling without a timeout, or treating token delivery as a full success without checking downstream acceptance, those are classic traps. Losing your session context, retrying every single error, ignoring downstream acceptance entirely, and logging sensitive secrets will very quickly drain your balance and cause your unattended jobs to just fail silently in the background.
Okay, let's dive into the developer FAQ and troubleshoot it.
Here's a classic troubleshooting question, and honestly, probably the most common one developers ask us. Why can a perfectly valid solve token be rejected by the target site? The answer is almost always right there in your session data.
Yep, the culprit is almost always mismatched sessions. If you trigger a challenge in one browser context or HTTP client, and then you try to inject the solve token using a completely different cookie jar or session, the target server is just going to reject it. The context absolutely must match seamlessly.
Next question. How do teams keep this integration stable in production over the long haul? And what exactly should they be monitoring first? Look, if you want to eliminate those late-night pager alerts, you really need to know exactly how to measure success.
The answer lies entirely in your KPIs. You need to wire these specific metrics right into your existing dashboards. Monitor your first solve latency at the P50 and P95 percentiles. Track your solver's success rate versus your actual downstream end-to-end acceptance. Keep a close eye on your costs per accepted solve to make absolutely sure wrong parameter loops aren't silently eating away your margins. And strictly cap your retries at 3 attempts with exponential backoff. These controls essentially act as your early warning system, highlighting regressions long before your users ever notice.
Here's another really great question. What happens if the site suddenly changes the Captcha family on the page? Say it goes from an image challenge to a token challenge. Normally, this is a total nightmare scenario for hard-coded scripts, but how does our Deno architecture handle it?
Well, the real beauty of this setup is that CaptchaAI exposes a single consistent API across all Captcha families. You don't have to rewrite your underlying logic. Because you're using one consistent API, you just swap out the task type parameter, keep your identical submit and pull loop completely intact, and simply ship the update. It is incredibly resilient.
Let's circle back to our core Deno feature for just a second. Why are import maps specifically helping us with workflow stability? Put simply, they completely prevent messy dependency graphs. By using import maps, the whole integration stays remarkably small, highly observable, and incredibly easy to hand off to another developer on your team. It keeps the long-term operational overhead extremely low.
Finally, let's cover safe scope and our main takeaway.
It's vital that we state this clearly. This type of workflow should strictly only be used in owned, client-authorized, or contractually permitted environments. CaptchaAI is engineered specifically to make authorized, legitimate setups predictable for developers. It is definitely not a recipe for circumventing protections on third-party sites where you have absolutely no agreement. We're building professional infrastructure here.
So a Deno plus CaptchaAI import maps workflow needs to be treated like true production infrastructure, not some fragile happy path demo. Reliable workflows absolutely demand clean imports, exact inputs, controlled polling, same session handoffs, safely capture retries, safe logs, and real downstream success tracking. Implement these practices and your automated workflows are going to be unbreakable. So I'll leave you with this final thought. If your unintended automation mysteriously fails tonight, is it just a random network issue, or are you simply losing your session context?